This video will look at controlled cross-tabulations. This series of videos is meant to provide a practical framework for doing simple statistical analysis in applied settings. There have been a series of videos presented so far, and each of them is assumed to have been watched before you watch this one, because each of them has information that feeds what we're doing here. It will be hard to understand what I describe here if you haven't watched the previous videos that set up the information you need to do this one. So there's this broad framework that I've constructed. It just draws the pieces and parts that most people in statistical work use, but tried to simplify it into a form that helps you to choose the right tools, be able to locate the kinds of results you need to answer practical questions, and then to be able to report those results in a way where an audience can understand where and how the question was answered. So in this framework that's set up for applied work, we have looked at a series of analysis questions so far. For example, in a previous video, we looked at what do people think of spending on national defense. In a previous video, we've looked at an analysis question, do people with different political views, being more liberal or more conservative, have different views of spending on national defense? And in this video, we're going to add a analysis question, is the relationship between view of spending on national defense and political view different for men than it is for women? We're going to continue to use the same data set and the same variables that have been used in the previous videos, so you're probably already familiar with them. I'm going to just flash these slides that show the codebook information, but all of this has been presented previously in the other videos. Okay, so what do people think of spending on national defense was answered. How do you do this? Why do you choose the tool you do? How do you make sense of your answer in the distributions video? Do people with different political views have different views on spending on national defense was answered in the crosstabs video. And now we're looking at, is the relationship between view of spending on national defense and political view different for men than it is for women? In the framework, we start out by deciding what kind of analysis we're running. The question is the relationship between view of spending on national defense and political view different for men than it is for women? So you can already see that we have a set of three variables involved, and they're actually all being involved in the research question together. They're not just being named to be looked at independently, as was examined in the distributions video, where a variety of variables were looked at, but no relationships between variables were considered, and thus they were using a one-variable analysis. This is more than a two-variable analysis, because I'm not saying, as I did in the crosstabs video, how does this independent variable relate to view of spending on national defense, and then how does this other independent variable relate to view of spending on national defense. In this circumstance, I'm saying, is the relationship between the dependent variable, which is the participant's view of spending on national defense, related to political view, liberal to conservative, and how does that relationship look within the categories of a third variable? In this case, I'm using a very simple control variable of biological sex. Okay, so we're going to use simple multivariate analysis, which means that anything that we're going to do, any tool that we're going to try to use statistically, has to fall in that row. And then in the framework, we ask ourselves, is the dependent variable, in this example, it's the person's view of spending on national defense, too little, the right amount, or too much. Is that nominal or ordinal, which would make it a categorical dependent variable, or is it interval or ratio, which would make it a scaled dependent variable? Well, as has been shown in previous videos, it's ordinal, and so we're going to have to choose our tool from within that column. In that column, we have three different statistical techniques that are presented, and we can see where the grid aims us at controlled cross-tabulations, which means if we're doing any kind of multivariate analysis, that we're going to look for, when we try to find the results that are going to let us answer the question, we're going to look for the shape of the pattern, the strength of the pattern, the statistical significance of the pattern, and now in this video we're adding specification. Again, as I said in the last video, I'm using this word slightly differently than other people do. Most people simply talk now about using statistical controls, but I want you to recognize that what we're doing here when we add statistical controls is we're figuring out how all the variables relate to each other in some model sense. And when we do that, as was discussed in the previous video on specification, When we do that, we're actually saying something about which variables go where in a model, as compared to just saying what are the results after statistical controls. And I think conceptually, that's the more important way of framing multivariate analysis in most applied settings. All right, so we have bivariate tables, and we now will have what we're going to call partialed tables or control tables. The original bivariate, two-variable table, had view of spending on national defense by political view. We looked at the results from that in the previous two videos back, and we're going to look at it again now, and we had to look at shape, strength, and significance. Now, what we're going to do is we're going to then look at the results just for men, a partial table, as they're called, just for men, and it's going to have the same two variables. The dependent variable will be view of spending on national defense, and the independent variable will be political view. And we're going to look at the shape, strength, and significance of that seemingly bivariate table just for men. Then we're going to do the same thing for women. We're going to have a partial table that's just for women, and we're going to look at the shape, strength, and significance there, which sounds like we're just running bivariate analysis. But because we ran what would seem to be bivariate results within the categories of a control variable, we will then have a specification. We're going to see what we learn about how the variables fit into a model from the analysis that use statistical controls. And to do that, we're going to compare and contrast the partial tables, the table for men and the table for women. Or we might even bring in the original bivariate table if that helps us to clarify as well. So let me jump over to the analysis program, and let's do some basic analysis. I'm going to go into the frequencies option here, and I'm going to choose contingency tables. What I'm going to want to do is I'm going to want to choose my dependent variable, which we've been using as view of spending on national defense. I'm going to put it on the rows for reasons I explained in earlier videos. And then we're going to put our independent variable, which is political view, into the columns. And this should look familiar from a previous video. We could then say within each cell, I want to see the column percents. And now I basically have that result. And statistically, now I have an ordinal table, as was discussed in the crosstabs video. This is an ordinal table, and I then need to use an ordinal measure of association to see effect size. Now, this has provided me with the results that I had in the crosstab. And I could basically now see how political view predicts, maybe even could be argued to cause, although that stretches beyond what the empiricism shows, but it is the reason we run these analyses, how it predicts or potentially could cause views of spending on national defense. Now, what I want to do is I want to know if this continues to matter after I control for biological sex. I'm going to put it in as a layer. And so now I have a larger table that basically shows me a table for men. I'll parse this out in a moment visually for you. A table for the women, and the original bivariate table all shown here. I'll show you this more in a moment. And I now have, I really don't need chi-square because I have an ordinal table here, but now I have Kendall's tau b for each of these tables, the male respondents table, the female respondents table, and the total for everyone. And I have a statistical significance p-value for all of them. All right, that's all it takes. Now I can take this and I can actually copy it, and I can drop this table into some other program. I can drop it into Word, I can drop it into Excel, I can drop it into PowerPoint, or whatever programs you're using, Google Slides, Google Sheets, whatever you're using. All right, let's jump back over now to the presentation here. This is a screenshot of those results. Now, what I want you to see is that you really have, at the bottom, you really have the original bivariate table shown right here. And if you look above that, what it's done is it's taken, if I highlight a particular number here, it's taken this 210 people who are extremely liberal or liberal, this 210 people, 105 of them were female, and they're in this female table right here. And 105 of them were male, and they're in this male table right here. Now, it isn't that you always have the exact same number of people. You had 71 slightly liberal men, and then you had 45 slightly liberal women, and so you had 116 total. So this bottom table, this is the same exact table that you got with bivariate cross-tabulation. And what we've done is we've built two partial tables that have parts of, or a partial sample that have parts of the full sample. And so you can see for men what the results are, and you can see for women what the results are. So if we look across this table, we see that, remember from the previous video that what we learned for the bivariate was that as people become more conservative, they are more likely to say too little is spent on national defense. 13% of those who were extremely liberal or liberal said too little. 21% of those who are slightly liberal said too little is spent on it. 30%, if I use even round rule, said that it was too little if they were moderates. And for the slightly conservative, it's 38%. And for the conservative or extremely conservative, 46% indicate that they believe too little is spent. So as you become more conservative, you are more likely to say too little. That's the shape of the relationship. And then we will, in a moment, we'll go on and look at the strength and significance. But you recall that from the crosstabs video. Now, for the men, we can look and say, do we see the same pattern? Do we see a different pattern? Because anything might happen here. We might actually find that for men and women, there are very different patterns. But when you lump them all together into one table, you see whatever the lump of them all together shows. But in this circumstance, we find out that the men's table looks very similar to the overall table. We have 11% of the liberals saying that too little is spent. We have 14% of the slightly liberals, 28% of the moderates, 33% of the slightly conservatives, and 49% of the conservatives. So we find the same shape for men. And we can say, what do we find for women? Well, we find that 14% of the liberals, 31%, 32%, 45%, and 43%. So again, we find the same shape. Let's back up just a second. Actually, I needed to make sure that we met the assumptions for these partial tables that are necessary for every table that you do in cross-tabulations. And the assumption that we've identified was that you have to have at least 30, hopefully more, cases in every category of the independent variable. Now that means for this partial table of women, we expect to have at least 30 cases that are liberals, at least 30 cases that are slightly liberal, at least 30 cases that are moderates, at least 30 cases that are slightly conservative, and at least 30 cases that are conservative or extremely conservative. And we do 88, 62, 199, 45, 105. Similarly, we find for the men 105, 71, 204, 73, and 117 people. So that's all good. We have enough cases that we can actually run percentages within those groups. If we had less than 30, now this is kind of a magic number. It's by custom. If you had 29, you might say, well, that's fine, or 27 or something. But at some point you say, we really have too few cases to be running percentages in a way that we trust. So we want at least 30. I personally really would rather have 50 or more, but I'm comfortable with 30. So what we end up with are these three tables all put together in one table. We have the original bivariate, we have the table for the men, we have the table for the women. And then we have the Kendall's Tau B results for everybody. Now, you remember for the total table, Kendall's Tau B was negative 0.282, and I warned you that that negative sign, which indicates a negative relationship, as one of the variables is increasing, the other one is decreasing, you have to be very, very cautious in believing any negative or positive sign on a measure of association associated with a cross-tabulation, because cross-tabulations usually are built from survey data. Survey data can actually have the labels going any which way, and it doesn't necessarily correctly identify the nature of the relationship. So I would encourage you to make sure as always, to describe the pattern in words in terms of a direction of effect. As this change happens on the independent variable, this change tends to happen to those respondents on the dependent variable. That's what I would encourage you to do, and not hinge too much on the sign. In some later techniques, we're going to look at the sign and we're going to be done. We're going to basically use the plus or minus sign to determine the shape of a relationship. It'll be really convenient. It's just with crosstabs, we can't trust them that much. Now notice that the original bivariate table had a strength that we said was weak, negative 0.282, and I talked about what we would consider rules of thumb for weak or moderate or strong relationships back in the shape strength significance video I did. And I said then that there's no firm agreement on this. Different people cite different statisticians, different stats books give different cut points. These are just rough guidelines for how to say, do I see a very weak, a moderate, a strong kind of relationship? And we said this one's a weak one. Now, it's also true for the women there. You see the 0.225. That's also a weak relationship. But for the men, I had a cut point of 0.3 to call it a moderate relationship. For men, 0.335, it's a moderate relationship. So this relationship between becoming conservative and believing too little is spent is stronger for the men than it is for the women. The number is bigger. And it crosses a sort of rough threshold that says that the relationship is weak for women, but it's moderately strong for men. So that's a difference between the men and women. We didn't see any difference in the direction of effect, in the shape, but we do see a difference in the strength. In terms of statistical significance, you can see that all of them have a probability value less than 0.001, less than 0.001, which is clearly, if it's smaller than 0.001, it's smaller than 0.05. And we, by custom, in the social sciences at least, use 0.05 as the threshold of risk we're willing to take in rejecting the claim that there's no relationship going on maybe out there in reality, and we just have in our data something that's not as representative as we would like it to be. So we're going to reject the null. We're going to say that the men have a moderate strong relationship where more conservatism leads to a view that we spend too little on national defense. And women, we have a statistically significant reject the null, same exact thing, just different ways of saying it. We have a statistically significant result that's weak, and they also, as they are more conservative, tend to report too little, we're more likely to report too little is spent on national defense. That's our result set. So you'll recall that in the framework, I suggest 5 guidelines that are going to protect you from misreporting things and help you to report things in ways that are most helpful to answer the questions that were originally posed. You want to describe the pattern in words. That might be the shape pattern, the strength pattern, the significance pattern, or the specification pattern. You want to provide statistical evidence for the shape, strength, significance, or specification. You want to stay true to the cases. You want to say what the cases are and not misrepresent which cases you're talking about at any given moment. You want to stay true to the measures. If you have a measure, a view on spending on national defense, then you need to make sure you stay with that and don't wander off into representing it as a measure of something else or represent it as, in some sense, experimental when it was a survey. You want to make sure you never misrepresent how the data was collected and what was actually measured. And then if you make interpretations, that is to say, if you say, you know why this is? It's because people are thinking this. You know what's causing this relationship? It's because of changes in the national political... All of those efforts to move beyond the empirical data that we have in our data set and the actual statistical results are fully legitimate to do. In fact, oftentimes it's what people want you to do, as I said in the previous video. But you want to keep it separate from your empirical statements of shape, strength, specification, and significance, because you don't want people to think you're misrepresenting your speculation, as reasonable as it may be, as logical as it may be. You don't want people to think that you're misrepresenting that speculation as empirical fact. There is a difference. It's valuable to do both. You just want to keep them separate. So if I look at the total table and I have those results, then I could basically say something like this, like I did in the bivariate table. As people are more conservative, they're more likely to say too little is spent on national defense. While 13% of liberal or extremely liberal respondents said too little, 21% of slightly liberal, 30% of moderates, 38% of slightly conservative, and 46% of conservative or extremely conservative people said too little. This is a weak relationship that is statistically significant. Tau b equals negative 0.282, and the p is less than 0.001. Now, if I stick in some editorial notes here, you can see that my first sentence indicates the shape in words, and then the next sentence indicates the statistics for shape as evidence. It gives those percentages within the categories of the independent variable. Then I have strength in words. This is a weak relationship. Then I have statistical significance in words, which you just say it is statistically significant or it is not statistically significant based on p being less than 0.05 or p not being less than 0.05. And so I provide the significance in words, and then I give the statistical numbers for strength and significance as evidence. One more warning here. Whenever you're reporting any statistical evidence, you need to make sure people know what you're reporting. So I can't just say this is a weak relationship and in parentheses say negative 0.282. There are so many different tools that people might use that you can't just say negative 0.282. You need to say tau b equals negative 0.282 so that anybody like me or anybody else who is more familiar with this stuff knows what tool you're using. Because we'll talk about this in a later video, but if you're doing central tendency, I've been in a number of circumstances where people report the average result. And I'll ask them, are you using a mean or a median? And they don't know. They just know some number was given them to as an average. And some of them will even say, well, it must be a mean because we're talking about the average. No, actually, the average or central tendency is reported in means, geometric mean, arithmetic mean, is reported in medians, is reported in trimmed there's trimmed means. There's a variety of different measures of central tendency that are all averages. There's a variety of measures of association. So in this circumstance, in every circumstance, you need to report what the tool is. That's part of giving your statistical evidence. Okay, p-values are always p-values. Some people, historically, actually we all used to report what the p-value came from. So if that p-value came from chi-square, or if that p-value came from things we'll learn later, an f-test or something, then we would always report that as well. That's become less common. There are, in almost all circumstances, only a few things it could be coming from, and the p-values, we have become less concerned generally in the statistical world, particularly in applied work, in reporting which p-value we're using. But there are some results where you can have multiple p-values on your results, and you have to choose the right one for what you're working with. Okay. So cases and measures would need to be discussed separately, and I've offered no interpretations in this example, although I could say, well, let's see, why would more conservative? Well, it's because, you know, the conservative political party in the United States has been proactive in trying to make national defense an issue, and so it's raised that awareness. Now, nothing in my data shows that. It just shows a relationship between political view and view of spending on national defense. It shows it for the bivariate, for the women, for the men. It might be that the political party has led those people that way, but frankly, it could be the other way around. It could be a variety of other things. So your logical interpretations of what you think is causing or explaining why a relationship exists need to be kept separate. And now we could do the same thing for the men. In fact, this is what we do in cross-tabulations. We consider the bivariate relationship, and then we look at the partial tables. This one will be for the men, the next one will be for the women, and we compare and contrast all of these different tables to each other. Particularly, we compare and contrast the men's table to the women's table in this example, but we could also bring in the bivariate table if it turns out that helps us to explain things better. So here are the results for the men. And when we go to report for the men, we find as men are more conservative, they're more likely to say too little is spent on national defense. In fact, this says almost exactly the same thing that my earlier results said. The numbers change, but the patterns are the same. You see that, right? You see that basically for the men, we found the same shape. We found a slightly greater strength, and we found the same, it was significant, as significance. All right. Now, women, we could do the same thing. I'm not going to take the time, but we could do a similar description of the patterns for women, and we would find, as you've seen, the same pattern. It's a weak, significant relationship where as women are more conservative, they're more likely to say too little is spent on national defense, and I would give statistical numbers to support those claims. Okay, so now, what's the point of all this? Well, the point was to see if controlling for sex gave us information about the relationship of these variables. If we were going a little further in this process, we'd actually begin to talk about, as I said in the specification video, we'd talk about which variables go where in the model. We're actually providing a test of some of that here. But fundamentally, we want to know if sex matters, male-female matters, for the relationship between conservatism, as I'm using the variable, and view of spending on national defense. And what we find is the results for both men and women are very similar to each other. For both groups, greater conservatism is associated with increased belief that too little is spent on national defense. The effect is a bit stronger for men than it is for women, but it's clear that sex plays almost no role in the effect of political view on view of spending on national defense. Now, I haven't given any numbers to evidence my claims of specific. I have specified how these variables all fit into a model. And I've said that basically gender doesn't matter. Well, sex, biological sex, doesn't matter for this particular relationship between conservatism and view of spending on national defense. Now, I assume that all my previous paragraphs are above this one. And so I don't need to restate all the numbers. If I didn't have those previous paragraphs in front of this one in my report, then I would need to here give the numbers. And I could say the percentages for men as they move across from liberal to conservative, the percentages for women as they move across from liberal to conservative, and the tau B values for both of them, and the P values for both. I could report all of that here and just give this result. As a general rule, I strongly encourage you to do all of these pieces. Describe the partial tables, describe the bivariate table, compare and contrast them. We might have said something else here. If the results had been different, we might have said something entirely different. We might have said, men have a strong relationship between conservatism and view of spending on national defense, and here are the numbers that show it. And women have almost no relationship on conservatism and view of spending on national defense. If we'd found those results, we might have been saying that women, we didn't even reject the null. We might have found it was not significant, the strength measure was near zero, and the percentages across the categories of political view were all about the same in terms of how much is spent on national defense. Not what we found, but if we had found that, we would then be specifying that gender, sex does matter. That in fact, a relationship exists between the independent and dependent for men, but does not exist for women. That's why we run these kinds of controls. We have reason to believe they might matter. You've surely been in a circumstance where someone has said, well, I think what's really causing people to behave that way is that they are, and you have some, they say some independent variable. And then you think, no, I don't think so. I think what you're describing is really caused by something else. Well, the only way to find out who is correct is to run the results, gather data, run the results analytically, and control for each other's independent variables to find out which one matters after controlling for the other. Sex does not matter in this circumstance. Now, I may decide that I want to do something in a presentation that's a little bit more graphic. So I took my data into Excel, and once I took it into Excel, I had to delete a bunch of different columns and rows, because when I copy it out of JASP or out of any stats program, it doesn't give it to me in the form I immediately need to build this stacked bar chart I'm going to build. And so I have to delete a bunch of stuff, move some stuff around. Then I have to copy it and I have to transpose it the other way around. And even then I had to move some stuff, and then I build a table. This video series isn't going to help you figure out how to build stacked bar charts or any kind of graphic, but it is here to say that building a graphic can be incredibly valuable. So let's say that I have this graphic. Let me make the video go away here. All right, so here's my controlled crosstab presented as a stacked bar chart. I might actually start out when I present it this way. I might actually give one-sided view, and all I've done here is in PowerPoint I dropped a box over one side and made it 30% transparent so that I show that there's more there, but I'm actually providing just a focus on the men's view of spending on national defense. And so you can see the pattern graphically. Now for some of you looking at this, you're seeing the pattern in a way that you didn't see it when we were looking at it just in numbers. And then I might shift and say, well, now here's the pattern for the women. And the benefit of doing a live presentation or this kind of a video presentation is that you can walk people through your results and you can show them the pieces. If you're doing a report, you don't have that choice. You could just present one half of this table as a graphic and talk about it, and then the other half as a graphic separately, and then talk about how they compare and contrast. Or you could just give the whole table as one table and talk about the results that way. Well, in essence, what we find is that controlled cross-tabulations are clunky, they're hard to work with, they involve a very large number of percentages and other numbers you have to sort between to try to answer your research question. But if you're working with a categorical dependent variable, there really aren't many other simple statistical tools available to you. This is where you would have to fall back to being able to answer your question. Hopefully, though, this provides you with some idea of how you would move through all the stages from one variable to two variable to multivariate studies of categorical dependent variables and the independent variables you believe matter for them. We will move on now in the next set of videos to looking at scaled dependent variables and what kinds of different tools and what kinds of different realities we have to wrestle with to do those.